Hello everyone. This is the last lesson in the vector section of the course. And in some ways it's kind of a bonus or a little bit of an extension. Okay. In the last lesson we looked at how to solve a system of three equations using the algebraic methods you've used before. Okay, this is just a quick side lesson showing how to use something called a matrix to do the same thing. So if you've taken data management at some point, you may have seen this technique before. And it's especially useful if you're going to go on in university mathematics. Like if you're going to take any kind of an algebra course, they're going to use matrices. Okay, so like for the purpose of this course, if you're fine with the algebra method, you don't have to worry about memorizing how this works. But I'm going to show it to you, and it's something for you to try out. Okay, but you don't have to use it. But again, going forward, you might see it in university. Okay. So a matrix really is just a table, okay, of elements. Okay, so what we use this here for is we make a table of all the different coefficients in our linear system. Okay, so for example, this was a system we solved in the previous lesson. So if I want to turn this into a matrix, okay, I just write down a big square bracket, and in each row, I just go across and write what I see. Okay, so I have x plus y plus z. So I have 1x, 1y, 1z, and that's equal to 7. Okay. In my next row, I have 2x, I have 1y, I have 3z, and that's equal to 17. Okay. In my last row, I have 2x, I have negative 1y, negative 2z, and I have negative 5. Okay. And when we're doing a system of equations with a matrix, we often draw a line here just to indicate that that's where the equal sign was, right? So this side is my x, y, z, and you don't write that down, but that's what they are. And the other side is a constant. Okay, so I'm going to go through the process explaining how this works in a moment, and then give you a chance to do some practice for that. Okay, so what we can do with a matrix in this form is we can do things that are similar to what happens with elimination. Okay, so these are called elementary row operations. So if we're using a matrix to solve a system of equations, these are some things you're allowed to do, and the matrix is considered to be not the same, but similar, right, as the same solutions. Okay, so the first one is, right, any row can be multiplied by a non-zero scalar. Right, so that first row I had that was 1, 1, 1, 7. Right, I won't fill in the rest here. Okay, if I want to, I can multiply that by, say, 3, right, and have 3, 3, 3, 21. Right, and it's still considered the same system of equations, right? And that's okay, because we know when we're solving a system, often you have to multiply an equation so you get, two coefficients to match up and you can cancel. So it's just like multiplying an equation by a constant. You can multiply a row by a non-zero scalar. Okay. Second one is any two rows can be exchanged. So if I have a matrix that has 1, 1, 1, 7, and I don't remember what the other one said, but let's say it was 1, negative 1, 3, and I don't know, 10. Okay, and there was something else here. If for some reason I think it's an advantage to switch their position, okay, I can just go rewrite this as 1, negative 1, 3, 10 as my first row, 1, 1, 1, 7 as my second row, and leave the third row alone. Okay, so I can just switch the positions. Okay, and again, because changing the order of the rows is just moving the equations around on the page. It doesn't change the solution. Okay. Okay, the last one. A row can be replaced by the sum of that row and a multiple of another row, or multiples of both, actually. Okay, what this step is really about is the elimination process. Okay, so let's say if I went back to my 1, 1, 1, 7, okay, and my second row was 2, 1, 3, and 6. Okay, if I was trying to do elimination, remember this is my x. So this row has a 1x, this has a 2x. Right? If I want to eliminate x, right, I would need to multiply my top row by 2. Okay, right? So I'd have a 2x there. And then I would subtract the two equations, and that would get rid of x. Okay, so I can do that all in like a single step in a matrix. Okay. So before I do that, I'm just going to do a little notation thing back here. When we make changes like this, we leave ourselves little notes so we can keep track of what happened. So that first one, right, when I said 1117 became 33321, okay, I leave myself a little note that says this is 3 times row 1, okay, because that's what I did, right? I just multiplied row 1 by 3. Right, so it's saying this is what I did to my last matrix to end up with this. Okay, and each rows can be exchanged. Okay, so what I would write here is that this used to be in row 2, and this used to be row 1. Okay, that was the switch I made. If I look at my previous matrix, oh yeah, that was row 1 over here. Look at my previous matrix, that's row 2. Okay, so if I want to do some elimination here, I could say in my next matrix, okay, so when I write down my new matrix, I would like to double the first row and then subtract the second row. Okay, and that would allow me to say eliminate x. Okay, and I'm not doing anything to the top row, so I just write it out again. Okay, and for my second row, okay, now I'm going to do a little bit of mental math here. So I'm going to scribble some notes as I go. Okay, if I multiply that top row by 2, I would have a 2, a 2, a 2, and a 14. So that's my 2 row 1. Subtract row 2. So 2 subtract 2 is 0. 2 subtract 1 for y is 1. 2 subtract 3 is -1. And 14 subtract 6 is -8. Okay, so I've basically mimicked a step in the elimination process and just wrote it all out as my new row in the matrix. Okay, so that's basically how the process works. So for the examples, I have them kind of pre-written out, so I'm going to whip through them fairly quickly and just kind of highlight what's happening as we go through. Okay, so here we go. This was the original matrix we had on the previous page, so maybe I should actually copy that out or bring it over. Okay, this is what we had, right? So my first step was, I know I'm going to eliminate these 2's here, so I'm going to go ahead and multiply that first row by 2. Okay, so that's all I did here from the previous slide, right? I took that and multiplied it all by 2. Okay, so now what can I do to eliminate x? Okay, well, I can take these different pairs and do some subtracting. So for instance, I could take my first row and subtract my second row and write it down here. I could take my first row and subtract my third row. Okay, so that's what I've done here. Okay, so I'll kind of highlight what happened here. So this one says row 1 times minus row 2. So I took this first row and subtracted the second row. So 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 3 is -1. And 14 take away 17 is -3. Okay, so that's how I got that row sitting there. Okay, I did the same thing on the bottom. Okay, so row 1 take away row 3. So I did 2 minus 2 gives me 0. 2 subtract -1 gives me 3. And 2 subtract -2 gives me 4. Finally, 14 subtract -5 gives me 19. And that's how I got that row there. Okay, because I was done with the elimination step, okay, I decided to put this one back as well. So 1/2 row 1, I just divided this by 2 and brought it back to look the way it did before. Okay, so that's what's happening there. Okay, and over here, I've just written down what's happened to my equations, right? My first row is still x, y, z equals 7, right? 1x, 1y, 1z, 7. Okay, my second row now says y, right? 1y minus 1z equals -3. My third row says 3y plus 4z equals 19. Okay, so we successfully eliminated x from these two rows. Okay, our next step in the process was to try to knock out another variable. So let's say we went after y. Okay, right? What would I need to do to eliminate y? Well, I need to multiply this row by 3, right? And then combine it with this row, right? Subtract it. Okay, so this time I did it all in one step. Okay, I wrote down that I'm doing 3 row 2 minus row 3. So again, I'm just going to jot some notes down here. If I went back to my previous matrix, 3 row 2, right? So that would put a 3 here and a negative 3 there, and this would have become a negative 9. Okay, so then I subtracted 3 minus 3 is 0. Negative 3 minus 4 is negative 7. Negative 9 minus 19 is negative 28. That's how I got that row. And this is telling me what I did to the previous line. Okay, so we eliminated y from our third row. Okay, what would be our next step in elimination? Well, I want to get the z by itself, so I need to get rid of this negative 7. Okay, so I divide both sides by negative 7. Okay, so I wrote that as negative 1/7 row 3. Okay. Usually we write it in terms of multiplication, right? It wouldn't be the end of the world if you wrote that was row 3 divided by negative 7. Okay, and that brought us to 1 and 4. Okay, so I've successfully solved for z, okay, and that's equal to 4. So when we got to this step in elimination with algebra, okay, we immediately said, okay, now let's start going back to the equations, substitute in z, and solve for x and y. Right, so I'm going to flip back again for a second. Right, I would have gone here and said, okay, z is 4, so I put a 4 in here, and I solve it for y, and once I've got y, I put it in here, and z, and solve it for x. Right, that's what we did before. Okay, with matrices, we often will keep going, and we'll keep using the same technique to keep eliminating things so the answer is just there. Okay, so that's this line right here. Working backward, we're going to use row 3 to eliminate z from row 1 and row 2. So that's where I am. Okay, I'm going to try to knock out z. So I need to get rid of it here and here. So starting with the first row, if I want to get rid of this 1, I have a 1 here. So if I did 1 minus 1, it would be gone. Okay. And these are 0, so it wouldn't change either of these. Okay, so I would like to take row 1 and subtract row 3. Okay, and that's going to get rid of the 1 in that lead position. Okay, what I'm doing here, right, row 1 minus row 3. 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. 7 minus 4 is 3. Okay, and I wrote it down there. So that means my top equation is really now just an x and y. This is x plus y equals 3. Okay, how do I get rid of the negative 1 in the next row? Well, if I added these two things together, negative 1 plus 1 would give me 0. So I'm going to add row 2 and row 3. Okay, so when I do that, again, 1 plus 0 is 1, negative 1 plus 1 is 0, and negative 3 plus 4 is 1. Okay, and what's handy about this, okay, even now, if I look at just this row, now this row says y equals 1, because x and z are both gone. So now I know z, right? Up here I knew z was equal to 4. Okay, and now I know y is equal to 1. Okay, so last but not least, okay, now that I figured out y, I'm going to use that row to knock out the y in the first row. Again, I happen to have ones, which is really nice. So I'll just take row 1 and subtract row 2. Okay, so when I do that, I have 1 minus 0 is 1, 1 minus 1 is 0, I have zeros, that's okay, and 3 minus 1 is 2. Okay, so the top line in this says x is equal to 2, right? X equals 2, Y equals 1, Z equals 4. So therefore, the point of intersection is 2, 1, and 4. And we're done. Okay, so that's how that process works. Okay, so I'm going to show just one more quick example of the same steps. With another matrix. Okay, and we'll go from there. So here's the original system. Okay, I've written out the coefficient matrix, right? So I have 1, 3, -1, and -9. Okay, 1, -1, 1, and 11, and 1, 2, 4, and 5. Okay, so if I wanted to eliminate x, for instance, here and here, okay, what would I need to do? Well, I could just subtract row 1, row 2. Okay, so 1 minus 1 is 0. 3 minus -1 is 4. And -1 minus 1 is -2. -9 minus 11 is -20. Okay, same with the last row. Okay, I could just do row 1 minus row 3. Okay, and I would get this line here. Okay, my goal now would be to eliminate y. Okay, I have 4y here and only 1y there. So I'd want to multiply this row by 4, and then I could subtract. Oh, sorry. I guess I decided to make life easier myself by switching those around. I should have read my notes a little bit beforehand. Okay, I switched the rows so I have a 1 in this position. Okay, but I'm going to do the same trick I was talking about. Although, that means I need to fix this. That's not right anymore. Okay, so this is 4, row 2, take away row 3, I believe. Nope, that is 4. That is row 3, take away 4, row 2. Okay. Right, so again, to show what was going on here, okay, I'm going to bump these up to 4, so it'd be 4, right, 20, and 14 times 4 is 56. Okay, so I would have had, it says row 3 minus 4 row 2, so 4 minus 4, 0. -2 minus -20 is positive 18. -20 minus -56 is 36. Okay, now I can solve for z by dividing both sides by 18. Okay, once I've done that, I can start working backwards. Okay, so to knock out z from here, okay, I could either multiply this by -5 and subtract, or multiply it by 5 and add. Okay, and same up here, I can just add row 1 and row 3 to make that knockout. Okay, so row 1 plus row 3, 1 plus 0 is 1, 3 plus 0 is 3, -1 plus 1 is 0, -9 plus 2 is -7. Okay, for row 2, if I multiply this by 5 and add, yeah, we get rid of the -5. Okay, so I multiply that by 5, and I have a 5 here and a 10 here. So 1 plus 0 is 1, -5 plus 5 is 0, -14 plus 10 is -4. Okay, final step, if I want to get rid of x, then I would need to multiply this row by 3 and subtract. So row 1, take away 3 times row 2. And what I'd be doing here is multiplying this row by 3. So I really have a 3 here and a -12. So 1 minus 0 is 1. 3 minus 3 is 0. -7. Take away -12 is positive 5. Okay, and now that I'm in this form, I can say my solution is 5, -4, and 2. Okay, so if you like the matrix method, you're willing to try it out. if you look at page 497, example 3, okay, that shows you some examples of how to use a matrix to solve a system where the solution ends up being a line, okay, not a point, right? So the two examples we just did were both type 4. They met in a point. This example shows what the process looks like if you're trying to get to an equation of a line, so for the type 3 system. Okay? And then there are some questions to practice the concept. Okay, so again, this is very similar to what we did yesterday, okay, just using a slightly different method. Okay. Whatever method you prefer, I am fine with, okay? I'm not going to force you to know both or anything like that. Okay, just whatever method you like better for solving systems, use the method that you like. Okay, thanks for watching.